Hello, everyone, and welcome back to Anthropology 310 Origins of Human Diversity. It is the 28th of August, and we are Wednesday of week 2 in the semester. Let's start off by taking a look at the syllabus. Here's our syllabus. Let's see what we got going on this week. So today we're going to continue our discussion of anthropological methods. We're going to finish talking more specifically about archaeology, but also the things we're going to talk about today also relate to paleontology, also paleoanthropology, study of ancient humans like fossilized human ancestors. We're going to be basically talking mostly about how we know how old something is, and this is a major question in the discipline, especially in archaeology and paleoanthropology, because something might be remarkable if it's from one date, but unremarkable at another day, right? If we find arrowheads in North America 2,000 years ago, it's pretty unremarkable. But if we find them 5,000, 6,000 years ago, wow, that's pretty remarkable because people shouldn't be having arrowheads yet or just starting. So maybe this is like the first instance, right? So dating really makes a big difference. We're also going to finish that up and then maybe have some time to get into a little bit of cultural anthropology as well. We'll see. We have homework number 1 due this week, as well as quiz number 1. Remember, now that ad drop deadline is here, you should all be in the class, and I'll start actually, like last week, I couldn't be grading too hard on whether you turn it on time because maybe you just added the class. But now everybody's set, so we'll have homework number 1 and quiz number 1 this week. I'll do on Friday. Let's take a look. This week, we're going to in quiz number 1. You'll be, this is some questions that we might be trying to answer this week in class. It's like we talked about last time, why it's important for archaeologists to not excavate everything at their field site. Today, we're going to talk about the difference between relative and absolute dating and why archaeologists use both to determine how old something is, why there's not a right answer. Usually in this class, if I ask you which is right, which is a better technique, relative dating or absolute dating? The answer is usually going to be, yeah, they're both good. They're good for different reasons, right? We'll talk about why that is. And then, like I said, we'll talk about a little bit about cultural this time. We'll really get into it next time. How do ethnographers learn about different cultures is methods in cultural anthropology? And what types of things could you learn from ethnography that you might miss if you use a different method like archaeology or biological anthropology to study humans? How does it add to our greater picture of human society? The other thing we're going to be doing on Friday in here when we talk about ethnography, we're going to be looking at Shakespeare in the Bush. I have a little video about that as well. We also, there is a reading for you to click right here on that. And you'll read this for your homework. It's 9 pages, but you know, it's pretty big font. And it's it reads like a story. You know, it's nothing too technical, nothing theoretical or anything like that. But it's a good example of someone doing ethnography, right? Moving to another place for a long period of time, living with a people and learning about their culture through this kind of back and forth of cultural exchange. So we'll read that and then we'll discuss it on Friday. So it'll help you if you read it beforehand. Again, it's an easy read. It's very literary, And then once you're done reading it and you've discussed it on Friday, only 3 questions about how does her interpretation of Hamlet as an American differ from the Tiv of West Africa? Give specific examples. Why are these different interpretations important? And how does her summary of Tiv relate to cultural relativism? So all will be revealed. That's what we're doing this week. Okay, let's take a look at the syllabus or the PowerPoint. Last time we were talking about archaeology, and we talked about some of the different ways that we do archaeology, or we differentiated between what archaeology is, right? Kind of studying the material remains of the past. We also discussed the different kinds of things that archaeologists found when they were doing excavations, like artifacts, things that are made by people and are portable. Ecofacts, natural items that people use. So I use this deer by making it into lunch, or I use this corn to make tortillas, and now there's some pollen left over. Fossils, hardened remains of animals or plants that have turned into stone. That's the big difference. We will be looking at bones in this class. Like we could look at the bones of someone from Blackwater Draw, right? And 12,000 years ago, the people who were here. There's no bones there, but a similar site. But those are probably not going to be fossils. Those are probably just going to be regular bones at that point. But if we go back 1,000,000 years, we're going to get fossilized stuff, right? So fossilized stuff is usually a lot older than the bones. We also have features. These are human-made objects on the landscape that you can't pick up and take back to the lab, right? House, foundation of a house, if you're doing historical archaeology, right? If you're working out at the Melrose bombing range, and there used to be farmsteads out there before it got turned into a military base. And we can find those foundations, right? Those are human-made artifacts that we cannot pick up and move. I mean, you could, but it would be pretty difficult. Whether that's a wall of the house, petroglyphs, or on a stone or anything like that. And finally, the site being the kind of larger overall area in which artifacts, ecofacts, and features are all found. And you can map this out on a piece of paper. We also talked about the difference between survey and excavation, right? Survey is where you usually walk, usually a transect or something like that. In the Southwest or in the American West, it's much easier because you can walk for just literally miles here and not hit a bush or anything like that if you're out in the desert. And it's much easier to see things on the ground versus if you're working in like Ohio or something, or West Virginia. It's going to also be very difficult to do surveys because you got up and down in the mountains, you got trees, you got logs, you got just, piles of leaf litter. And so it's much harder to find arrowheads or something, but you still find them. Survey in general is considered non-destructive, which means that you can run the same survey multiple times. I mean, you are picking up if you find an artifact, marking it, sometimes putting it in your bag, sometimes putting it back. But in general, not destructive to the larger site. On the other hand, excavation is much more destructive because it involves digging down. You're oftentimes breaking through layers. So like the house that I excavated in Belize at Caracol, there were 5 different houses built on top of each other over a period of a couple hundred years, right? Because it was a really good spot right next to the palace. So you got good access to those rich people with their money. And people would build a house and it would fall down. They'd build another house on top. Problem is they would put plaster floors down. That's why people still plaster their floors today. But when we were digging down, because of the way the houses were, you had to actually physically break through these well-preserved plaster floors, which was pretty cool. And it was kind of sad to break them, but you couldn't actually get through them in any other way. One of the questions on your quiz this week, right, is why don't archaeologists, excavate everything at a site? And that's part of the reason. Like we only excavated part of it, right? So we could leave these other floors intact. So later archaeologists could either do more studies or they could see for themselves, this house was here and then they built this house. And in between there's a layer of gravel and then there's another house, right? It provides the strata for what they're doing. We saw a video last time about the ways that we excavate, some of the tools we use, like a trowel. We can use a level. We can use graph paper and pencils to draw what we find. Tape measures to measure how big something is and how far something is, right? So I found a 3-inch arrowhead and it is, 16 inches from the edge of this wall in a house, right? We can be precise instead of just being like, yeah, I found a bunch of arrowheads out there and they're just all over the ground, right? This helps us kind of reconstruct the site because it is destructive. We want to take as much data as we can before we cover the site up. Because a lot of times at the end of the season, spoiler alert, there's not like there are big warehouses full of archaeological stuff, but it's super expensive to maintain. And so a lot of that stuff just goes back in the ground, right? We just put it back in the hole and cover it up because there's nowhere to put it. No lab, no Indiana Jones giant warehouse full of treasures that we're just hiding from people. But if you're going to put it all back and it's all going to be messed up again, it's important to like document what you did first, right? So we take pictures, we draw pictures, we draw graphs, we take measurements. That way, either digitally now with computers or back in the old days on graph paper, you could physically reconstruct that site. And you'll see a lot of archaeological texts that are just site drawings. Like if you see the Blackwater Draw one, it's like a drawing someone made of all the, where the mammoth bones were found and how each bone is articulated, right? So even though that you can't go see it in person now, you can look at those pictures and you can see, well, this mammoth was here and it still has all its parts. And this one was disarticulated. They took the head and the legs off. And what does that mean, right? Did they butcher it? Did something else happen, right? Okay, we're going to talk about, pretend you're an archaeologist you've discovered something cool. You discovered a pottery, right? A piece of pottery. It's got a cool picture on it. This is going to make me famous, right? Discovered some pottery. But how do you know how old that is? What are some ways? Yeah, radiocarbon dating. It doesn't work quite so well on pottery because you need carbon. Usually they don't have any, but sometimes there's stuff in it, right? If there's like corn in there or they used it in a fire, you can have scorch marks on it. What's another way we could tell? That's a form of absolute dating, and we'll talk about what that is. Yeah. Yeah, you could use some of those other sciencey techniques like a thermoluminescence or something like that. Talk about some of those. You might also be able to do what's called relative dating. What's relative dating? Yeah.
This far in the strata, we know that 2 stratas down, it's so and so years old.
Yep. Yeah, right. Like if I am looking at excavating a church in northern New Mexico or something like that, right? I know the church was built in 1521. You have historical records that Spanish people came and built this church, or 1598 or whatever, right? 1598, we'll say. And then the church collapsed and they rebuilt it on top of it. And I find a piece of pottery between the first and second church layers. I know that pottery was not there before 1598, right? Because I know what the date for that bottom layer is, and I know it has to be more recent. Yeah. Yeah, we can do relative dating on artwork. We can see how that changes over time. We can even use tree rings, and we'll talk about that in a little bit. But in general, when we talk about dating, right, and this is not what we would say in cultural anthropology, like dating and marriage. This is like dating, how old something is, right? There are 2 big, broad categories, and we'll talk about some of the differences within those categories in a second. But in general, relative versus absolute dating. Absolute dating, I think, is probably the easiest one to remember because you get an absolute date. This can be a specific year. A great example is I found a coin, found a Roman coin in my excavation in Turkey or wherever I'm digging. Could that give me an absolute date? It might, right? This was in usually it wouldn't be like 15 AD, but it might be like in the 3rd year of Caesar Augustus's reign or something like that. Or even I might just have a picture on the coin of who was Caesar at the time. And if I can't get an exact date, I might get a range, right? I know that Marcus Aurelius was emperor for 15 years or something like that, right? And so I can say, well, this coin was minted somewhere in that reign. It's not going to be earlier than that, right? Because they didn't know anything about Marcus Aurelius 50 years before that. And it's probably not going to be after unless it's some kind of like commemorative coin, right? It gives us a date. This date can either be a single number. I can find a penny that says 1950, and I can be like, wow, that penny was made in 1950, right? And that can help us date other things. We find other stuff on that same level, right, on the floor that we're excavating, and I find pennies from 1950, but no pennies from the 1960s. What does that tell me? Yeah, it was sometime before 1960 when that floor was deposited and covered over. Put it in a coin collector.
Yeah.
Yeah. And you could say, you know, it is probable, right? We're in science, we're talking about probability, but Occam's razor, you may know who Occam's razor is, or what's that all about? What's that? Yeah. Yeah, right. If I find a bunch of coins that I can date from Marcus Aurelius's reign in ancient Rome, you know, maybe 300 years later, there was a coin collector and he had collected a bunch of the stuff. He fell in that pit and died, but it's unlikely, right? And that's why we're going to use multiple lines of evidence to really put this together, right? Again, like your question on the quiz this week, it's not enough just to use one or the other. We're going to use multiple lines of dating, and that's going to help us really lock down when something happens, right? Because if everything is pointing in the same direction, it really lets us know that's probably a good hypothesis versus if we have some outliers. Absolute dating can be a specific year. 1950 is what my penny says. or it could be a range, right? Whether it's, the reign of Marcus Aurelius, or it's, when we do radiocarbon date, oftentimes it'd be like, this is radiocarbon dating to 1280 plus or minus 50 years, right? It can have different range around either side, but still it's going to give you an exact number, right? An actual number. We're talking about relative dating. We don't have actual numbers, but we have comparative sequences, right? Something is old, something is older, something is oldest. We can do this using stratigraphy. We did this last time. So assuming nothing is disturbed, which is older, the stone idol or the skull in this top picture? Assuming nothing has been disturbed by gophers or anything like that, which is older in the top picture, the stone idol or the skull? Which is older? The skull. And how do we know that? Yeah, it's deeper, right? It's further under the ground. So barring any kind of mix-up, which does happen, and here's a great example: building can fall down and the walls, which were higher up, can now be lower. Or there's a construction site. We find this if you work in the Middle East doing archaeology, it's often confusing because people build on top of each other. Also in Mesoamerica, you'll build on top of an old site, and sometimes you'll dig down to like foundations. Things will get mixed up. Or, for instance, there's a lot of churches that you find in southern Mexico, which were built out of the bricks of the old Maya pyramids. The Spanish pushed them all over, and rather than make new bricks, they took the rocks out and built a church, right? So you can mix things up and you can change the layer. You might find a hieroglyph. I was sitting in church one time, doing like you do in church and looking at the pictures on the wall and stuff. And I look at the wall and there's hieroglyphs on the wall. And that's weird for being in a Catholic church. And it turned out it used to be a pyramid. They pushed it over. They built it up. So if that church is ever buried under again, you might find those hieroglyphs in the wrong layer. You're like, oh, that's from 2000 or something. So when we do, again, this is just a great example. You can do relative dating and absolute dating on the same sample. Here's a stratigraphy of some layers of rock. We can do dating, whether it's, it's too old to be radiocarbons, probably uranium or something like that. We can get absolute dates for these different layers, but we can also layer them and count them from youngest to oldest, right? Again, these methods don't work in opposition to each other. They work together. They're friends. Let's finish up our, when we're talking about relative dating, we'll finish that first. Oftentimes we can do what's called chronology, right? What am I showing you here in this picture of a bunch of different Coke bottles from different years? You can see, I don't know if you can read that. Different Coke bottles, they're all Coca-Cola bottles, and it says the year, 1899, 1902, 1916, 1915, 1957, 61, 91, 94. Yeah.
Their shape and design have changed?
Yeah, how the shape and design have changed, right? Well,
Glass to plastic?
yeah, so we can talk about the material has changed from glass to plastic. What else do you notice about the change? Yeah, the logo has changed. It's kind of interesting. The logo itself is kind of similar throughout. Well, you can see this label right here looks very different from this label. What else can we see in this picture? Yeah, right. There's long periods of continuity where it's kind of the same for a long period of time, right? Between like the 60s and the 90s, probably it's pretty much the same. But then we get this big shift between the 1991 last glass bottle and 1994 switch to plastic, right? And that's a major shift. So we can see change and discontinuity, but we can also see continuity in this, right? Is there a logical sequence that these are following? Does it make sense, like one design to the other? Right? Oftentimes in culture, you're going to find these kind of iterative designs. People aren't going to go start with this glass bottle, then switch to a plastic bottle, then switch back to this brown glass bottle, right? There's like a logical sequence. Things build off each other and they evolve from each other in the same way that we could look, at dinosaur fossils and see how they've evolved over time. And so once you can kind of make a sequence or a chronology, you can use this as a form of dating, right? Once you find, you can tell which bottle goes in which place. This bottle is from the 50s, so I can identify it. But you can also see how things change stylistically. Coke bottles are an easy example because we're familiar with them, but a great example of this is with pottery. right? These are different kinds of pots. This is Southwest pottery. Over time, you got different types: plain black, plain red, polychrome, Pecos glaze, and glaze 4, right? One thing that's interesting about when you look at these types of things, this is like seriation, is that things change over time, but oftentimes there's not an abrupt end to a certain type of thing, right? So while this is kind of looking at time, this is 1080, this is to 1800. These spikes or these curves right here are showing you the relative frequency of a type of pottery over time. And here's some picture examples. Which type of pottery came first in this chart? You don't have to know anything about the Southwest. You just have to figure out this graph. Which one? Yeah, glaze 4, right? How do we know? Because we can see that it starts showing up like 1450 and then it ends by like 1500. And then we go to this one, Pecos 5. Then we see some of these three later ones: plain red, plain black, and polychrome. But what's interesting, I think, is that there's not a clear distinction. Maybe in the way that like the switch from glass Coke bottles to plastic ones was pretty overnight because it's one major manufacturer or sub-manufacturers. Coke, Coke's going to do its thing. Versus in a situation like this, you have different people, right? Different families and different villages making this pottery. And so you have some overlap, right? We see this glaze 4 starts out, it's really popular, but then it starts to decrease as people switch to glaze 5. And even though, these other newer forms show up later on, about 1600, we still get glaze 5 hanging on almost all the way till 1800, right? So we can look for the frequency of an assemblage in the archaeological record and figure out when something is, right? So if we find, once we've kind of done this at a number of different places, if we find a whole bunch of glaze 4 pottery, even if we don't do any radiocarbon dating or don't find any pennies or anything with it, what might that tell us? If we find just a bunch of glaze 4 and we've already kind of established this as the pattern for the region, what's a good hypothesis about when this site is? Yeah, right. It's from the 1500s, probably. And it could be an outlier, right? Maybe you're going to get famous because you discovered a site that had glaze 4 back in 1300. It was the first one. Or you discovered this survival, right? This group of people who, in whatever reason in their village, they decided to keep on hanging on to glaze 4 like till 1800. But generally, once we've kind of established a frequency, we can date things pretty accurately using the relative frequency of the type of artifact we found. And it's not just pottery, it's not just those people, right? It's not just indigenous material culture. There's a really famous archaeological study of gravestones in New England. It's one of my favorites. We did this in my intro to archaeology class. New England gravestones. Yeah, let's see if I can find it. All right. So in New England, right? You all know where New England is, like where the Pilgrims and stuff are up in Massachusetts and Connecticut and things like that. It's one of the first areas of English settlement in North America. We're all New Mexicans, so we all know about the New Mexico side of, or the Spanish side of colonization. But in the English part of the colonial Americas, you get these really cool gravestones, right? And they're all decorated differently. Well, they're not all different. There is a lot of variety. You get some of these with like these very like, I don't know, seems very heavy metal to me, right? You got like skull and crossbone or like skull with wings. Other times you got these angels. Other times you get like crosses. Here's another one of these kind of winged things. Very distinct. You get this kind of tree and urn architecture or design like this one right here. And what's really interesting is that gravestones are a form of absolute dating, usually, right? Why? Yeah, right. It tells you when you're born and when you died. And even if they don't know when you're born, they probably know when you died because they put a gravestone there. But the problem is sometimes the gravestones are broken or they are weathered. And you can kind of see, here's an example, right? This one you might be able to read the date on, but that one, it's pretty rough, right? It's been out in the rain. They probably had some factories down the road in the 1800s and acid rain and stuff washed off some of the carving, right? how might we be able to determine, just based on the pictures at the top, if we have, let's say, 99 gravestones with dates still on them, we have one without one, how might we use the 99 that we do know to determine when that mystery one is from? Yeah, right. So I can look at two variables on each gravestone, right? If I have the information, what is the picture on the top and what is the date of death, right? Date of birth is not quite as important because sometimes people live 20 years, some live 100 years, right? And I can say, yeah, the skull and crossbones is found primarily between 1650 and 1680, in which they switched to skull with wings. And by the time of the American Revolution, they've started doing this like tree and urn design. Where is it? Like this, right? And so then if I find a tree and urn design, I have a pretty good idea. Again, it's not 100%. I'm going to use other lines of evidence, but I have a pretty good idea that this person is from a specific era, right? It's a good example of how relative dating can support absolute dating. The other reason you use relative dating is that it's cheap. There are a lot of times when like it'd be cool to do radiocarbon dating or thermoluminescence, or I'm going to do potassium argon dating, but that costs money. Each time you send a sample is thousands of dollars to the lab, and you got to write grants to get that money because I don't have that kind of money to send off pieces of bone to get analyzed. So we can't radiocarbon date everything. But a good technique is to radiocarbon date a few things from different layers and kind of get a baseline of where different things are in this chronology, and then kind of go back and fill things in the middle. Again, it's probably more accurate if you were to test every single little thing. But again, we only have so much time and money to do this. So we can use relative dating as well as absolute dating to put it together. Next, we're going to talk about absolute dating, right? We've already kind of alluded to it with specific dates. But there are a variety of different techniques which we can use. And I'm going to show you this video. It talks about the differences between relative and absolute dating. And I think relative dating is pretty easy. I think you probably all have a good idea of it. But it talks more about absolute dating and some of the methods which I'll introduce in just a moment. Those of you following along at home, I'm going to pause the video while I show this, and you can watch it in the Canvas module. Okay, that video was a great introduction to relative and absolute dating, as well as showing us some of the physics and chemistry of how absolute dating happens. So we've kind of talked about what is relative dating and kind of hopefully have a good idea of that. They mentioned in the video radiocarbon dating or carbon-14. This is primarily what we use in archaeology, right? Because like you saw in the video, this technique goes back to about 50,000 years. Usually it's more like 25 or so, right? The further back you go, you're dealing with smaller and smaller amounts, and it becomes much harder to figure out that ratio. But it works really well for archaeology because, we don't get things like domestication until like 10,000 years ago, the rise of ancient civilizations like 6,000 years ago. So when we're talking about things like from the last ice age or, ancient Egyptian pyramids, or when did people live at Blackwater Draw, these are all kind of things we might use radiocarbon dating for. And actually, did you hear last year there was a new site found at White Sands? They found some footprints of humans from like 22,000 years ago, and the archaeologists claim it's the oldest footprints of humans in North America. And the way that they did that was that there was a layer of, they used both relative and absolute dating, right? Because you can't date a footprint, right? It's not a carbon signature. It's just an imprint. It's never alive. But what they found was the people were walking on kind of a soil or a mud, kind of a beach. And right underneath that was a bunch of organic matter, right? Plants had died on that beach, and there was some sand on top, and they were walking. So they could date the organic matter just below the footprints and the organic matter just above the footprints, right? So we get absolute dates based on those two layers, and then look at the footprints in between. And so that by doing that, so this layer is 23,000, this layer is 21, so we know it has to be somewhere in the middle. Again, this only works for things that were formerly alive. So if you build a house out of sticks, that's great because we can date it. If you eat corn or you eat some deer or something like that, we can all date that. But if you're building your house out of bricks or stones, we're going to have to use a different technique. Another technique, which I really like, and is especially cool in the Southwest, is called dendrochronology. When we talk about dendrochronology, it's tree ring dating. Anybody from Albuquerque here? Yeah. Have you ever been to the Natural History Museum? My kid loves that, right? When you're going in there, kind of on the bottom floors, there's that giant tree section that they've cut there, and you can see all the different tree rings in there. And then they mark on the tree, and they'll be like, Columbus landed during this time, and this is when the Spanish came to New Mexico, and this is when George Washington was alive and stuff like that. And this is today. Yeah. The fatter the rings mean that it's a wet year because the tree is growing more. Skinny rings mean the tree is not growing as much. It's probably a drought. The layers closer towards the middle are going to be the older rings, right? Because the tree was a little tree then. And then as trees age, they get bigger. They put layers on top of them. And you might say, that's cool. So what, right? Each of these layers usually, it doesn't work as well in the tropics for a number of different reasons. But in North America, especially in the Southwest, this is one of our favorite ways of dating things, right? There's an assumption, and this has been proven, that especially in the Southwest and other places where you have these wet and dry cycles, you can really see the rings, right? You can say like this is a summer and this is a fall or something like that, right? The fat because you're getting, or in the winter it's getting more moisture, so it's a fat ring, and in the summer it's it's pretty dry, so the tree's not growing as much. And you can count those backwards, right? What's really interesting is that if you have a piece of wood, so for instance, this tree right here, this cross section, this is if I cut a tree down and I took a cross section. You can take a core out of a tree in the same way you might do like a ice core or something. I take a core out of that tree, and I can see, I know when this tree was cut down because I cut it down with my chainsaw or whatever in 2013, whatever year. And I can count backwards, and I can figure out when that tree was planted by counting back rings, right? So I've counted back enough rings, and I can see that this very first layer is going to be 1924. Right? That's interesting because it's an absolute date. But what's really interesting to me is that trees from the same region will follow the same patterns, right? And especially like in the Southwest where it's not too wet, in Belize, it's terrible for doing this because it's not only rains all year, so the trees just grow all year, but also it's always wet and everything molds and rots. But in the Southwest, it doesn't. And so you can go into some of these historic houses in Santa Fe or in Taos and look at the vigas, and you can see those tree rings, and you can be like, huh, I noticed a familiar pattern, right? So this is my tree I cut down in 2013, and I knew was started growing in 1924. I can see this kind of relative pattern of wet year, wet year, wet year. Oh, a couple dry years, wet year, more dry years, right? And then I'm, going to architectural salvage in Santa Fe because that's what I do. I'm rich, not really. But if I was, and I found some posts, and I said, hey, that looks very familiar, right? I see another pattern. I see this this pattern of dry years, 2 wet years, and a bunch of dry years. I might know that this lines up, and we actually have a database in the Southwest which lines up tree ring samples. And so you can find a tree ring, and if you know generally what region it's from eastern New Mexico or something like that, you can pretty well slot that piece of wood into a particular absolute date. And what's really cool about the Southwest is because we have petrified forests down here, we have dates going back more than 1,000 years of using this kind of absolute dating, and it's super cool. We do this in you can find out when a building was made or when a structure was made or when a piece of art or something was made based on the rings down to a very specific year. Yep, dendrochronology. There's a bunch of other dating methods as well. Not only just carbon-14, but you can use potassium, argon. You can also use uranium. Those are all they're all good techniques, but they tell you different ranges, right? Uranium is going to be for a much older date, and carbon's going to be a younger date. You can do also things like thermoluminescence. This will be for like if you're firing something or if there's something out in the sun. You can see kind of how the rock has aged based on how much luminescence it has on it. But primarily in this class, we're going to be using things like radiocarbon dating for much more recent archaeology things, pyramids and ice age caves and things like that, while things like potassium and uranium for fossils, millions of years old or hundreds of thousands of years old. Okay, we are just about out of time. Yeah, we're out of time. So I'm going to save the cultural, starting on cultural till Friday. So that's a good kind of introduction to archaeological methods and how we might do something in archaeology. And next time we're going to talk about some of the methods in cultural anthropology. We're also going to introduce you to Shakespeare in the Bush, that your homework for this week. And then next week we'll jump into some methods in biological anthropology. Don't forget that Monday there is no class because it's Labor Day. So. All right, that's it for today. Thanks so much for hanging out and learning about relative versus absolute dating. I'll see you next time.